In May 2026, a Bengaluru-based startup unveiled a 155mm artillery barrel that weighs 70% less than the steel version it replaces. This is the first instance of carbon fiber composites being used to replace monoblock steel in a heavy-caliber weapon system. Traditionally, platforms like the Advanced Towed Artillery Gun System rely on massive forged steel barrels to withstand the extreme internal pressures of a firing shell. A standard 155mm steel barrel weighs approximately 1,400 kilograms. This weight creates a massive logistical constraint in high-altitude environments like the Himalayas. Narrow mountain passes and low-tonnage bridges often make it impossible to transport 12-ton artillery systems to the strategic ridgelines where they are needed most. This is a technical breakdown of Donta Innovation's all-composite barrel. By wrapping a carbon fiber matrix around a high-durability liner, they have reduced the barrel's mass from 1,400 kilograms to just 420 kilograms. If you want to stay ahead on global defense shifts, subscribe to the Global Warwatch network right now. This material shift addresses a specific geographic bottleneck. It allows for the deployment of heavy-caliber firepower in terrain that was previously limited to much lighter, less powerful weaponry. The engineering relies on the specific strength of the carbon fiber matrix. While steel needs thick, heavy walls to contain internal gas pressures, this anisotropic composite structure is engineered to handle those same hoop stresses with a fraction of the material thickness. Thermally, the composite barrel maintains its dimensional stability during rapid firing. Because carbon fiber can be engineered with a near-zero coefficient of axial expansion, it eliminates thermal droop, the structural bowing caused by uneven heating that usually degrades the accuracy of steel barrels. This weight reduction enables new deployment methods. An artillery system utilizing this barrel can be light enough to be sling-loaded under a CH-47 Chinook helicopter, allowing batteries to be airlifted directly onto isolated high-altitude peaks. On tracked platforms like the K9 Vajra, the weight saved by replacing a steel barrel can be repurposed. Engineers can add thicker, blast-resistant armor to the turret and chassis without increasing the vehicle's overall weight or sacrificing its power-to-weight ratio. This pursuit of lightweight, long-range hardware extends down to individual weapons, as seen in the development of the Prabal revolver. The 32-bore Prabal uses a 700-gram frame and a side-swing cylinder. Its internal ballistics give it an effective range of 50 meters, which is more than double the reach of the standard 20-meter range found in most domestic revolvers. From heavy 155mm howitzers to sidearms, the strategy focuses on stripping away dead weight to ensure high mobility without compromising the weapon's reach or lethality. To survive contested territory, ground assets need integrated air cover. This forces a shift from historical procurement toward total ownership of aerospace technology. Historically, India's aerospace sector relied on screwdriver Gary, assembling foreign-designed aircraft kits under license. While this provided domestic production, it did not provide the design know-how or intellectual property needed to develop original flight platforms. The current shift focuses on building that sovereign capability. The Cabinet Committee on Security has approved 15,000 crore rupees specifically for the prototype development of the AMCA, a fifth-generation stealth fighter designed entirely within India. Foundationally, this requires domestic engine production. Strategic partnerships with GE Aerospace and Safran are now transitioning toward the local manufacture of high-thrust engines, ensuring that future fighter wings are powered by technology owned and produced on Indian soil. Relying on foreign assembly lines for critical defense assets leaves a military vulnerable to supply chain disruptions. Dominance in the air now depends on owning the underlying supply chain and the engineering IP behind the engines. The financial engine driving this aerospace expansion is the commercial sector. Events like Wings India 2024 demonstrate how military modernization is now anchored by a rapidly growing civil aviation market. Commercial demand is surging, with air passenger traffic increasing 20.6% year-on-year. Massive fleet expansions, including the introduction of the Airbus A350, are providing the industrial volume necessary to sustain high-tech aerospace manufacturing. Global aerospace leaders are anchoring this domestic growth. Boeing has invested 1,600 crore rupees into a new 43-acre engineering and technology campus in Bengaluru, their largest investment of its kind outside the United States. This ecosystem allows local startups to solve niche engineering challenges. For example, Time-Tooth Technologies recently designed the country's first indigenous passenger aircraft seat, filling a long-standing gap in the domestic aviation supply chain. The growth of the civil sector provides the capital and infrastructure needed to support specialized military production. This commercial volume ensures the manufacturing base remains viable during the long development cycles required for defense hardware. Across ground, air, and commercial domains, the industrial base is moving away from importing obsolete hardware and towards exporting original innovation. This growth is fueled by a fusion of resources. By pairing the speed of private deep tech startups with the manufacturing scale of established defense public sector units, the time from design to deployment is shrinking. Ownership over everything from carbon fiber barrel production to fifth-generation engine design builds the foundation for a self-reliant technological ecosystem. Thank you everyone for your time and participation today. If you found this breakdown valuable, please like, share, and subscribe to Global Warwatch Network. We want to hear your thoughts. Share them in the comment section below, and be sure to join us on social media. The links are provided in the description. See you next time.